Hello. On this video, we're going to see how to solve exponential equations using the one-to-one property. And that means finding a common base on both sides of the equation. So on the first example, we have a base 3 and a base 9 exponential expressions. So our main goal is to have both as a base 3 exponential. So that means that we have to work with that 9. If we have a 9, we want to rewrite that as a base 3 exponential expression. So 9 can be written as 3 squared. So that way we will have a base 3 on both sides of the exponential equation, and the equation will turn into 3 raised to the power of x is equal to 3 squared, and that will be raised to the power of x plus 1. Whenever we have an exponent raised to a different exponent or another exponent, we have to multiply the exponents. So this will become 3 raised to the power of x is equal to 3 raised to the power of 2 times x plus 1. So that means that the 2 is going to be multiplying both the x and the 1. So this is going to end up as 3 raised to the power of x and 3 raised to the power of 2 times x plus 2. Now that we have a common base, we can use the one-to-one property, meaning that we're going to be focusing on the exponents only, since we already have the same base. That means that we can set x equal to 2x plus 2. And once we have that, we just have to solve for x in order to find the actual value. And that will be minus 2 if you feel like solving for x on the right-hand side. Minus 2 is equal to 2x minus x. And that will end up as minus 2 being equal to x. If we substitute that on the exponents, we shall be getting the same value. But I mean when you have the same base. So if we substitute on this version of the equation right here, and we substitute that minus 2, we're going to end up with 3 raised to the power of minus 2 has to be equal to 3 raised to the power of 2 times minus 2 plus 2. So that will end up as 3 raised to the power of minus 2 is equal to 3 raised to the power of minus 4 plus 2. And that is exactly what we wanted, having the same thing on both sides of the equation. So that means that this is the solution on that particular equation. On the second example, we need to find a way to get the same base on both sides of the equation. Base 9 and base 27 doesn't look like we're going to be able to turn that 27 into a base 9 exponential. But what about turning both into a base 3? So this is going to be 9 can be written as 3 squared, and 27 can be written as 3 raised to the power of 3. So that means that we're going to rewrite this with a common base as 3 squared, and that will be raised to the power of 8 minus x, and then 3 raised to the power of 3, and raised to the power of x minus 3. So just like on the previous example, we're going to have 3 raised to the power of 2 times 8 minus x, and 3 raised to the power of 3 times x minus 3. Now we have to multiply the 2 by the 8 and the minus x. So this will end up, or you could use the one-to-one property from that moment, but I'm just gonna rewrite it as 16 minus 2x is equal to 3 raised to the power of 3x minus 9. Having that, we just have to use the one-to-one property by setting 16 minus 2x equal to 3x minus 9. And it's just a matter of solving for x. So that's going to end up as 16. We're going to add 9. And then we're going to have 3x plus 2x. So that means we have a 25 here and a 5x here. So at the end, x is going to be equal to 5. If you want to corroborate your answer, if you want to make sure that you did everything right, you can substitute the 5 on this version of the equation. You could do it here, but this is going to be more straightforward work because you're going to end up with the same base and the same exponent. So this is going to be 3 raised to the power of 16 minus 2 times 5 is equal to 3 raised to the power of 3 times 5 minus 9. So that's 16 minus 10 is going to be 3 raised to the power of 6. And 3 times 5, that's 15. Minus 9, we get the same 6 as before. So that proves that our answer is correct. So it's just a matter of same base, then the one-to-one property, and solving for x.